All right, with our next example, we're going to look at the graph of r equals 3 minus 2 sine theta. So some of us might be nervous because first of all we see a minus, but actually that's not really a big deal with these graphs. How is this different than the previous? Well, in the previous, we've looked at one where these two numbers were the same, and we've looked at one where the amplitude was larger than the shift. So now it's the other scenario of the shift being larger than the amplitude. So let's think about what this is going to do. So I think we've kind of reviewed enough about sketching original graphs for us to maybe try to combine some of this, right? So it has a vertical shift of 3. So I'm going to go ahead and move kind of my anchoring invisible axis up 3. And then this means my wave height is 2, and the negative in the front simply means we reflect it vertically, right? So normally sine starts at 0, that's my new 0. Then normally it goes up 1, but it's been reflected and we've stretched it to 2. So we're going to go down 2, back to 0, up 2, back to 0. So we're really getting this lovely graph here, boom, something along these lines. So now I'm going to go ahead and label my coordinate points for my polar. So this one is at, nope, every time. It's at a height of 3 at the angle 0. This one's at 1 at the angle pi over 2. This one is at 3 at pi. This guy's at, what is that? That's at 5. I can count. Everything's fine. 3 pi over 2. And then we're back down to 3 at 2 pi. So this one's got some interesting things going on. Let's go ahead and count off if you haven't yet. We got to go all the way up to 5. Perfect. That was horrible. Okay, I'm going to stop beating myself up over these graphs and just hit pause, and then everything's great. All right. So let's go ahead and start out at a radius of 3 at 0. And then we're going to cross through quadrant 1 down to a radius of 1. So this is going to be kind of a weird shape, but it's kind of like that heart we had previously where we're trying to like take up as much as we can of that space. Then in the second quadrant, we're going from 1 back to 3, radius of 3. So we're going to kind of make that shape a little bit. And then we're going to, well, this might be a little exaggerated, Miss Wright. These aren't going to make quite the same shape as the heart guy. Like it's not going to make a cusp. That's the important part here. The cusp is only going to occur when you go all the way back to 0. All right, and then in the third quadrant, we're going from 3 to 5. So 1, 2, 3, 4, 5. And we're trying to take up as much of this space as possible. And then 5 back to 3 in the last chunk. So very symmetrical. Hey, that wasn't too bad. Okay, so these are related to the Limacon, actually more than they're related to the heart. Because these numbers don't match, they're not really in the same category as the cardioids are. So it's actually considered a Limacon without a loop. All right, and if we think about why, it has a lot to do again with the amplitude versus the shift. Remember, the negative didn't really make my life that horrible. It just flipped it from where I'm usually used to seeing it. But the fact that the shift was larger than the wave height means that we never quite reached 0. And we definitely didn't cross through it like we did on the one that did have the loop. So that means it's never going to quite reach the pole, and it's going to kind of make this more convex figure.